Hi, hello everyone. So today we are going to learn on trapezoidal rule. So trapezoidal rule is used to approximate integration. Yeah. So let's say you have this integration I equal to, you want to integrate from a to b for this particular function dx. So trapezoidal rule, this is the formula for it. So you have h over 2, and then you have fx naught plus 2 fx1 plus 2 fx2 plus, and then plus 2 fxn minus 1 plus fxn. Okay, and your h is equivalent to b minus a divided by n, and you have to take note here that n is the number of subinterval. Okay, so you need to memorize, you need to understand, in general you need to understand this formula for trapezoidal. So for example, let's say we have sorry about that. Let's say you have questions like this. You want to integrate what is I for this particular functions. So from 0 to 0.8, and this is the function that you have, 0.2 minus 2x squared plus 40x5 dx. Now, before we begin, okay, one more thing. And for this particular example or questions, you need to approximate the integration using n equal to 4, meaning that you need to have 4 subintervals. All right? So before we go further into how to use the formula, let's look at the concept first. So let's say that you have, let's look at here, this is your A, then this is your B. So this is your A and this is your B. So your A starts from 0 until 0.8. And the question asks you to approximate using 4 subintervals, right? So what does it mean? It means that you need to plug in into this formula here. So you have h equal to b minus a divided by n. So our b is 0.8 and our a is 0, divided by, remember that we have 4 subinterval, the n. So this is going to be divided by 4. So you will have 0.2. What does it mean? It means that you need to divide your interval, your whole scale from 0 to 0.8 into 4 subinterval, and this is the gap. So the gap is 0.2, 0.2, 0.2, and sorry about that. Okay, this is 0.2, 0.2, 0.2. It means that the point after 0 is 0.2, and the point after 0.2 is 0.4, 0.6. At the end, you have 0.8. So you're going to evaluate all the functions for this f0, f0.2, f0.4, f0.6, and at last f0.8. Okay. Then what you have is, remember that you have these functions here. Okay, so this is your fx. Right. So you need to evaluate your F0. So F0 means you have 0.2 and minus 2 multiplied by 0 to the power of 2 plus 40, 0 to the power of 5. You just plug in into this. You just plug in into this function, yeah? So this one you will get 0.2. Now you need to evaluate function when x equal to 0.2. So when you plug in into this 0.2, and this is 0.2 to the power of 2 plus 40 multiplied by 0.2 to the power of 5. So then this one you will get 0.1328. Next is F 0.4. Then this one is 0.2 minus 2. 0.2 to the, sorry, this is not 0.2. This is, yes, this is supposed to be 0.4 to the power of 2 plus 40, 0.4. This is repetitive task actually, if you see it. So this one is 0.2896. And next is you have function which you need to evaluate at x equal to 0.6. So that will give you 0.2 minus 2 times 0.6 to the power of 2 plus 40, 0.6 to the power of 5. So that will give you 2.5904. And then you'll have F 0.8, which is 0.2 minus 2, and then you just plug in 0.8 plus 40, 0.85. So that will give you 12. Sorry about that. 12. My pen is running out. 12.0272. Okay. So at the end, what you need to do next, you see here that you have evaluated all of these functions, and you need to plug in into this formula. Yep. So I need to rewrite this again. So this one, imagine this is the continuation from this line here. So it's going to be h over 2 multiplied by f naught plus 2f 0.2 plus 2f 0.4. Those are the functions that you already evaluated. 0.6 plus f 0.8. I hope you can see it. Okay, so this is the one. Now you just plug in. Remember that you already calculate your 0.2 as your h. So you need to plug in here 0.2. Sorry about that. 0.2. Okay, remember that we have evaluated our function f naught or f x at 0. So this is 0.2 plus 2 times function when x equal to 0.2 is 0.1328. You just plug in into the formula. 0.4 is 0.2896 plus 2 multiplied by 2.5904, and finally is 12.0272. Just take note that in the middle, when you look at this formula, all are multiplied by 2, multiplied by 2, multiplied by 2. It's just that the first entry and the last entry, you don't have to multiply with 2. Alright, so that is the formula for the trapezoidal rule. And when you evaluate this, at the end, you will obtain 1.82528. So this is going to be the value, the approximation value. So this is the approximation value for this questions here. Alright, so you can also, based on this, you can also have the error. So how to get the error? Error is we have a true value minus the approximation value. Okay, I'm going to continue this at the next example or next video. Thank you very much.